The moon didn't just appear. It's the result of a violent collision somewhere around 4.5 billion years ago. A Mars-sized object called Theia slammed into early Earth, hard enough to melt rock down to vapor. That impact threw molten debris into orbit, and over time, that material clumped together to form what is now our moon. This is called the giant impact hypothesis, and it explains why the Earth and the moon share so much chemistry. The same oxygen isotopes, the same fingerprints of our early terrestrial crust. This collision also tilted Earth's axis and set up a 24-hour rhythm of day and night that we live in now. Ever since then, the moon has been slowly drifting away from us. It's drifting away from us at about 3.8 centimeters every year. We know this because astronauts from Apollo 11 and later missions left panels of mirrors on the surface of the moon. Using these, we can fire lasers at the panels on the surface of the moon. We can then measure the amount of time that it takes for that laser impulse to travel to the moon and back. We do this over enough time and we can measure how quickly the moon is drifting away from us. All of this happens because of tidal forces. The moon's gravity pulls on Earth's oceans, creating bulges. But Earth spins faster than the moon orbits it, and so those bulges get dragged slightly ahead. Then the ocean bulge tugs back, pushing the moon outward and stealing a little bit of Earth's spin energy in the process. Because of this, our days are actually very slowly getting longer, something like 2 milliseconds every century. Now imagine, far in the future, when the moon drifts so far it can no longer block out the sun. Because of this, we are very slowly losing total solar eclipses, and with them, one of the most awe-striking natural laboratories in all of space physics. Now, when I say slowly, I do mean it. We won't lose a total solar eclipse for another 600 million years, but travel forward in time with me to this point, and we will no longer have these eclipses. Only rings of fire. For centuries, those moments of total darkness helped us study the sun's corona. That helped us track solar flares and even confirm Einstein's theory of relativity in 1919, when starlight bent around the sun just as his equations predicted. Today, space-based coronagraphs create those eclipses artificially. Satellites like SOHO and the Parker Solar Probe use these to monitor solar storms that can knock out satellites or power grids here on Earth. Even now, the moon still surprises us, just like when it shows up in the middle of the day. Where does the moon go during the day? If you've spotted it high in a blue sky, you're not imagining it, it really is there. Earth spins once every 24 hours, giving us our day and night cycle, something we call the diurnal cycle, but the moon follows its own 29.5-day orbit. Each day, it shifts slightly eastward, rising about 50 minutes later than the day before. That's why sometimes it's visible before sunset, and other times it's already set long before dawn. Around its first or third quarter, it's high enough and bright enough to stand out against daylight. The moon does not make its own light. It reflects the sun's. What we see, the waxing, the waning, the full moon or the new moon, depends on how much of the sunlit side is facing Earth. Because the lunar surface is covered in fine, glassy dust that we call regolith, it reflects sunlight unevenly. It's bright on the highlands, but darker on ancient lava plains that we call maria. Altogether, the moon reflects about 12% of the sunlight that hits it. That's about the same brightness as worn asphalt around noon on a sunny day. That reflection is what makes it visible even during the day, when the contrast between its gray surface and our blue sky is just enough for our eyes to catch. Throughout human history, the moon has guided time, harvesting crops, sailing across oceans, and creating stories that we pass down through generations. We know the moon doesn't shine, that it reflects. Maybe this is true about us as well, that in some sense none of us create light alone. Maybe the idea is that we just need to learn how to angle ourselves towards something a little bit brighter, a little more positive. What is it that you think about whenever you look at the moon? Do you wonder how it got there? Do you wonder what stories have been created using its presence? Do you wonder what it'll be like in the future with those rings of fire? All of this is the purview of a space physicist with an imagination. And if you enjoy videos like this, then make sure you subscribe. Also, the best way you can support me right now is by liking and sharing the video with other people who you think will actually enjoy it. Thank you very much. Cheers.